Hi everybody. In this video, we're going to look at constant acceleration due to gravity. We'll work through 4 questions, and if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So if we begin with question 1, we're told that a ball is thrown vertically upwards with a speed of 15 meters per second from the ground. We need to find the time of flight of a ball. So the best thing we can do is to sketch a diagram. We have the time, and then we've got the trajectory of a ball. Its initial velocity is 15 meters per second. We also have gravity, which is acting vertically downwards, and we're showing this with a double arrow. Because the acceleration is going downwards and the initial velocity is going upwards, A is going to be 9.8 meters per second squared. So we're going to resolve vertically upwards. This matches our initial velocity. We have a displacement, which is 0 because it goes up, but then it ends where we start with 0 displacement. The initial velocity is 15. The final velocity we don't know. The acceleration is negative 9.8. This is due to gravity acting against the motion of a ball. And the time is what we're trying to find. Because we don't need v, we'll cross out the formulae with a v term. So we're going to use this one. So the displacement of 0 will be the u, which is 15, multiplied by t plus 1/2 of negative 9.8 times by the time squared. We can simplify the t squared term, so we'll have 0 will be 15t minus 4.9 t squared. We can factor out the t, so 0 will equal t lots of 15 minus 4.9t. Now we know this t equals 0 when we're about to launch a ball, so the t we're looking for is at this point, which will come from this bracket. So 15 minus 4.9t must equal 0. So 15 will equal 4.9t, and this works out as 3.06 seconds. So it's really important that when we try questions like this, we sketch a diagram and we label the acceleration. We also need to be very clear as to which direction we're resolving it in. If you're to resolve it downwards, then this acceleration would be positive and the initial acceleration would be negative. Let's try question 2. So now we're told that a rock is thrown vertically upwards from a platform 5 meters above the ground with a speed of 20 meters per second. So do you want to try and sketch this yourself? Think about the trajectory of a rock and identifying the unknown values. Okay, so we've got the ground. The rock is thrown vertically from a platform 5 meters above. So we'll have this platform, which is 5 meters above the ground. And the rock is being thrown in this direction, vertically upward. And this is time. The initial speed is vertically upwards, and this is 20 meters per second. And we know acceleration is due to gravity acting downwards. So if we resolve vertically upwards, we'll have our SUVAT. We want to know the speed of a rock when it is 10 meters above a point of projection. So that'll be at this point where this distance is 10. So our displacement is 10. The initial velocity is 20. The final velocity is what we're trying to find. And acceleration is negative 9.8. So because we don't want the time, we'll cross out each of these. And we're going to use this one. So v squared will equal u squared plus 2 times the acceleration multiplied by the displacement. So v squared will equal 400 minus 196. This gives us 204. We'll take the square root, and v works out to be approximately 4.28 meters per second. How did you get on with that? For part B, find the speed with which the rock hits the ground. So if we write out our SUVAT again, The speed at which it hits the ground, well, the ground is 5 meters below the point of projection, so the displacement is now -5. The initial velocity remains 20. We still want to work out the final velocity. The acceleration is still -9.8. So we'll use the same formula. We'll have v squared will equal 20 squared plus 2 lots of -9.8 multiplied by the displacement -5. So we get v squared will equal 498. So v works out as 22.31 meters per second. Okay? So it's really important to think about the displacement. Because we wanted 10 meters above the point of projection, this is going to be positive. For part B, because the ground was below the platform, the displacement is now negative. Remember that displacement includes direction. Let's try question 3. So do you want to read through this question yourself, sketch the diagram, and consider the displacement really carefully? You can pause the video and come back when you're ready. Okay, so welcome back. If we sketch the diagram, we've got the ground, and the particle is projected vertically upwards, so the trajectory against time is similar to this. The initial velocity is 22 meters per second, and we want to work out the time for which it is 18 meters or more above the point of projection. So I'll draw a line here, and this will be 18 meters above that projection. So for our SUVAT, displacement will be 18, the initial velocity is 22, the final velocity we don't know, acceleration is -9.8, and the time is what we're trying to find. So we're going to use this equation here. So 18 will equal 22 times t plus 1/2 of -9.8 t squared. We'll move a t squared and a t term to the left hand side. So we've got 4.9 t squared minus 22t plus the 18 equals 0. We can solve this on our calculators, and we get t is 1.07 seconds and t is 3.41 seconds. So you can see this on our graph. We have this time, which is 1.07, and this time, which is 3.41. So it's above 18 meters between the 3.41 seconds and the 1.07 seconds. This is 2.34. Okay? How did you get on with that? Let's try one more question. So finally, for question 4, again, do you want to read through this question and try and work out parts A and B? Okay, so welcome back if you had a go. So our diagram, because it's being projected vertically downwards, we'll have our line, and it's being projected in this direction. I'll call this Q. And we're told that the ground is 60 meters below the point of projection. So we'll say that this is 60. And the speed is going to be the 6 meters per second. So it's much easier in this instance to resolve vertically downwards. We also know the gravity is acting with that motion. So the displacement will be the 60. The initial velocity is 6. We haven't been given the final velocity. A is 9.8. And we don't know t. We want to work out the speed with which it hits the ground. So we want to work out the final velocity. So we're going to use this equation here. So v squared will equal 6 squared plus 2 lots of the acceleration multiplied by the displacement of 60. So v squared will equal 1,212. We'll take the square root, and v will equal 34.81. meters per second. And then for part B, find the time it takes to reach the ground. Well, it's easiest now to use V equals U plus AT. So 34.81 will equal 6 plus 9.8 multiplied by the time. We'll solve this equation. 28.8 will equal 9.8 t, so t will work out as 2.94 seconds. Okay? Well, thank you for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.